Okay, so see how it says solve using elimination? All right, when you have two equations and they're asking you to solve, you could actually refer to these two equations as a system. So it might actually say like solve the system of equations using elimination. And why are they calling it a system of equations? Because there's more than one. All right, so if they actually said solve by graphing, that would be exactly like the last problem that we just did, like number 33. You just graph them and you see where they intersect. So this answer right here, once we get this answer, what is it going to represent if we actually were to graph it? Yeah, but like let's say this answer was like 8, 5. What would 8, 5 mean in terms of these two equations? It's well, let's say one graph's like that, and one graph's like that. It's where they intersect. It's the point of intersection. So there's 3 ways that you could find a solution to a system. So 3 minutes ago we did one of the ways. So what's one of the ways that you can actually find what these answers are? And that's what we just did in the previous problem. So how would you find this point of intersection with the only skill that you have? What's my question? No, how do you find this point of intersection using your current knowledge? You graph them, and then you see where they intersect, and then you find out. There's 3 skills you need to have, but you know one of them, and I'm going to teach you 2 more today. So I said with the only skill you have, you can graph them. So graph them. If you graph them on graph paper and a ruler, you'll find out the point that they have in common, and you have your answer. You with me? All right, so hold on a second. What's the first equation? 10y equals 18. And what's the other one? Y equals -9. Oops, -9. Okay, so -9x minus 10y equals -9, you said? All right, and it says find the solution. So looking at it here, where would the solution be? Like, what does it mean graphically, the solution? Like, when they say find the solution to a system, what does that mean? I know you graphed it, so I graphed it, but what does it mean? Like, if you were to get the answer? Yes, the point where they intersect. So here, it looks like, look, what does it look like the intersecting point is? -9, 9. And this looks like a little bit of a hassle to graph, to be honest with you. So, all right, so we kind of know, because we graphed it, we solved it graphically, that the answer is -9, 9. Like, you've submitted that, it would probably be right. Right? But we didn't do it the way they wanted you to do it. How do they want you to? They want you to use the second method. The second method is, what's that? Elimination. My personal favorite. Because you don't need a graph. So you'll get the answer without needing graph paper. You don't need a ruler. You just eliminate. And so the way this works is you stack the 2 equations. So 8x plus 10y equals 18. And -9x minus 10y equals -9. Okay, and by eliminating, you want to add straight down. So add straight down, and you want to make sure that one of the variables, either x or y, wipes out. And if it doesn't wipe out, you have to multiply the entire equation by like a number, some sort of number that makes it wipe out. So this is an easier one because one of them is automatically going to wipe out. All right, so which one of these, can I go like that or can I go like that? Can I wipe out the x's or can I wipe out the y's? The y's, because it's going to be 10y minus 10y, which is 0y, which you don't have to write. You just go like this. okay? And then now you add straight down. So now we have negative 8, positive 8, so it's 8, and then minus 9. So adding straight down just means follow the signs. So what's 8 minus 9? All right, so you're going to go negative 1x, and then over here, you add straight down, which means you just subtract those guys. So what do you get with the other ones? No, right here. You get 9. Okay. Now, how do you get x by itself? All right, divide by negative 1, divide by negative 1, and we find that x, so this wipes, and then we find that x equals what? Negative 9, and you see over here how we've already found that out from the graph? Okay, so now what we do is we get this negative 9, and we plug it into either this equation or this equation. You get to pick. You just pick one. You pick the one that seems kind of easier. So these look kind of the same. So let's just do the top one. So we go x equals negative 9, and you plug that in for x right there. So I'll just set it up. So it's 8 times negative 9 plus 10y equals 18. All right, so what's 8 times negative 9? 72, negative 72. And then plus 10y equals 18. And then, now what? Okay, plus 72, plus 72. And let me add it. 18 plus, you say 92? 90, okay. And then divide by 10, divide by 10, and you're going to find y equals 9. Okay, and then now you put it together as a coordinate, like something comma something. So what are we going to put? Negative 9 comma 9, because that's the x and that's the y, and that's that. So what method is this that we just did? Why is it called elimination? So what did we eliminate like in the beginning? Yeah, so we eliminated it. All right, the other way is substitution, but let's get elimination down first. All right, so this one is slightly different than the last one. Do you know why? Why not? Right, and they have to have what? Yeah, they have opposite signs. So what you're allowed to do you know what you're allowed to do? Okay, so you want to multiply the entire thing, either the top one or the bottom one, by negative 1. So if you do that, all the signs get changed to their opposites. All right, so what do I write for my new top? 5y equals negative 10. So opposite, 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 right? And then the bottom stays exactly the same. Negative 10x minus 7y equals negative 10. Now we can eliminate. So what do I do? So gone. Okay, now what? Negative 2y equals, follow your signs. So you could put this in your calculator like this. Negative 10 minus 10. You just So negative 20, divide by negative 2, divide by negative 2, and we find y to equal what? What'd you say? 10, okay. Now what do I do? You plug this y value. You plug this y value in one of the two original ones. Okay, so you plug this y value into one of the original. Sure. So you plug this y value into one of the originals. So which one do you want to plug it into? Okay. So just plug it into the OG. Don't plug it into like the new one here. Plug it into the one that's way up here. Just ignore that. Wait. Okay, so negative 10x minus 50 equals 10. Then what do we do? Okay, plus 50 plus 50. That's gone. Negative 10x equals 60. Divide by what? Divide by what? Wait, divide by what? Negative 10. Negative 10. And x equals what? All right, so we're going to get, we have our answer. We have our solution. So x equals, oh, wait. One more question. What does this mean in terms of the graph? What is the point of this coordinate? And if you were to graph these two lines, you do know this. You actually know this. I promise. You do. 100% you know this. So this is a line that graphs like this. This is a line that graphs like this. This is negative 6, 10. So what is the point of negative 6, 10? That, well, they intersect no matter what, but that's where they intersect. So negative 6, 10 is the coordinate of where those two lines intersect. So if you were to graph them, you could, like on graph paper and a ruler, you'd find that same point of intersection. So what's the benefit of doing elimination versus graphing? Exactly. Okay, exactly. Graphing is harder and easier to mess up on. Okay, so this equation is different than, or this system is different than what you've seen so far, because why? You can't wipe anything out. Even if you like multiply one entire thing by negative 1, does that help your situation? No. How come? Yep, nothing to cross out with. So all you got to do is you got to find like one of these that you can, like something from here that you can turn to that. So do you want to turn this 2 into a 4? I mean, that's really the easiest thing to do. Turn that 2 into a 4. Otherwise, you got to turn that into a 15, and you got to turn that into a 15. It's easier just to turn the 2 into a 4. So I like to do this in 2 steps. So the first thing I do is I multiply the entire bottom by 2. All right, so if I multiply, so I'll just copy the top. Copy the top in red. 4x plus 5y equals 13. All right, so rewrite the bottom. What do I get? Right there. 4x. Wait. 4x plus, what's 2 times 3? Yep, you can't just, it's like this, like 5 plus 5. Yep, look, 5 plus 5 equals 10, right? And it's like a balanced seesaw. You can't just go like that, and that, first of all, doesn't look like a balanced seesaw. Okay, that's a terrible seesaw. There's my seesaw. See, so I can't just put a 2 here and be like, oh, 5 plus 10 is 10. That's wrong. So I have to multiply the entire thing. I got to go 2, 2, and then 2. So then if I do that, what do I get here? No, what do I get? Just right there. 10. And what do I get next to that? And then what do I get on the other side of the equal sign? Does it still work? Yeah, so you have to do everything. All right, so you get 4x plus what? And then over here again equals 14. All right. Now, I don't like to multiply everything by negative 2. Are you watching? Because I feel like I'm going to mess up. Too much thinking going on. So what I like to do instead is at this step right here, because I can't wipe out. Why can't I wipe out? How come I can't go like that? There's no negatives, right? So what you do is at this step, just change all the signs to their opposites on one of them. You just pick the one you just did. So that's opposite, and then that's opposite, and then this guy right there, negative 14. Make it negative 14. 2. But tomorrow is an hour and a half. Okay, go straight down. What do you got? Wait, so I should write right here. So in case you look at these notes. Then multiply by negative 1. Then multiply, because I don't know you're going to look at these notes. Multiply bottom by. Okay, then, so go straight down and you're going to get your white. Well, pow, negative y. What? The negative y? Or this right? Yeah, I did. Okay, negative y equals. Alright, negative y equals -1. I'll just write that over here because somebody wrote that too big. Alright, now what do I do? Wait, negative y equals -1. What do I do? Just like that? So so this is an invisible -1 right here. So divide by -1, divide by -1. That wipes, and you get y equals what? 1. All right. Are we done with the problem? Did we solve? What does it mean to solve again? What does it mean to solve a system of equations? You're finding. What'd you say? What'd you say? You're getting a thing. What's a thing? A coordinate. And what is so important about that coordinate? And if you, like, what it show on this graph? It shows where the two graphs meet. It shows where they meet. Okay. So once I get y equals 1, what do I do with that? Perfect. Yep. Wait. Plug it back in. So 4x plus, you're going way too fast for me. 5 equals 13. 4x plus 5 equals 13. That looks like a j. All right, and then minus 5 minus 5 minus j. 4x equals what? 8. All right. 8. Divide by 4. Divide by 4. X equals what? 2. So what's my answer? What is my point of intersection between these two lines? 2, 1. All right. And one more problem. This one here. All right. So this is the worst case scenario, I guess. It's actually very similar to the last one. No. Let me think. Oh, it's not really the worst case. Go ahead. No, that was we've done elimination this whole time. We've been eliminating this whole time. Now the last step in elimination involves substitution. Like there's like when you like plug something in for something, that's substituting. But this whole method is eliminating because whenever you do this for this type of problem, no. But for more difficult SAT problems, yes. Like, yes. So you want to be able to like have that. But wait, there's one more thing. Actually, I'll just do this exact same problem, but I'll do it the harder way, so you can see what I'm talking about. Hold on. Okay, so I'm going to take a problem that we did earlier, which is this one right here. Oh yeah, the one right above it. And I'm going to do it a much harder way, just to show you like how you can tackle like the worst case scenario problem. Okay? All right. So you see how the first time around we turned this guy right here into a 4. Why did we do that? But sometimes you'll end up with what you said you had to because there's no other ones that are the same. But sometimes you're going to get something like this. And I don't want to make it up because it'll just be disaster. But you'll get something like this. No, I'm going to show you what it looks like. I'm not going to solve it because it'll end up like not working out perfectly. But you'll get something like this where it's like that. Okay? And yeah, like there isn't like one number I can apply to the bottom that will make it match up with the top. And there isn't a number I can multiply by the top that'll make it match up with the bottom. So in order to do this one, I would have to multiply the entire top by, do you know which number? 2. Okay, and if I did that, what would I get? 36. Okay, and then I multiply the entire bottom by what? No, because then it'll give me a 4. I want to get a 6. 3. Okay, so then I get what? Because that way, see if I did it right here, what do I get? So yeah, because I don't want to match up 6 and 7 with something they haven't. Yeah, I would have to multiply. The other thing to do is multiply this entire thing by 17 and this entire thing by 6, and that'll work also. So it's just easier to do it the other way. All right, so if I do multiply by 3, what do I get? Hold on. 17 times 3, 51 equals what? I think you said it. What was it? 15. Okay. Am I ready to go right now? Exactly. So how would I do that? God, why can't I do 5? Plus 51y. All right. So what would I do now? Okay, so opposite sign on the bottom, right? So if this was, let's say this was array negative, I'd make it a plus. So I would have to go boom. If I were you, I would erase this plus to make things confusing. And then minus, and then minus, right? Now you have your wipeout. When you plug back in, by the way, let's say this actually worked out and you found x equals 3. You don't have to plug into your more difficult ones that you created. You can plug in back to your originals. You see? All right, so the hardest part is actually done once you're wiping out here. So we're not going to do this made up one because it'll just be crazy fraction answers. So we're going to use a hard method on the problem we know that works out for sure. And what we're going to do is we're going to make sure that these two match up. After you do one of these successfully, then you'll do substitution. Okay, go. So I'll rewrite it over here. So 4x plus 5y equals 13. And 2x plus 3y equals 7. Okay, so what am I going to do? Sure. You can just, but I want you to match up these, because it's really easy just to multiply this one by 2, right? So we're going to do the harder method to match up the 5 and the 3. So what do? No, I'm matching up these guys. We're going to wipe up because I know this problem works. I understand, but I'm giving you the harder one. Just do the 5 and the 3. Okay, 5 and 3, go. Okay, now what do we have? Okay, then what do we get in the bottom? Good. And what was the point of doing what we just did? We got to opposite sign them, right? Like if this was negative, then you have to put a plus there. So you have to opposite sign, opposite sign, opposite sign. I would delete the middle, just so you don't get confused. Put a negative. All right, now what? 15s are gone. Now what do we got? 2x equals 4, okay? Divide by 2, divide by 2, x equals 2. Now what do we do with that 2? Yeah, you can do that. So you're going to plug it back to the original. And don't plug into these. It'll work, just way more work. And you'll get, so plug into that, you're going to get 2 times the new 2 plus 3y equals 7. So then you get 4 plus 3y, 7. All right, minus 4, minus 4. 3y equals what? 3y equals 3. Divide by 3, divide by 3, and y is equal to what? And so we get 2, 1. So I got the same answer up there. All right, so you've seen every scenario that could come up with elimination. Any questions on elimination?